Welcome to the Charles River Flood Model Results Viewer tutorial video. This interactive model was created by Weston and Sampson, Charles River Watershed Association, and Charles River Climate Compact, also referred to as the project team. In this video, we will explain step by step how to use the Charles River Flood Model. Step 1. Accessing the Flood Model Results Viewer, or commonly referred to as the Flood Model. To access the Flood Model, type bit.ly/cr-flood-model into your browser. Once there, you will see a pop-up window. This pop-up window covers the terms for accessing and using the flood model. Please read and agree to the terms before accessing the flood model. Step 2. Understanding the flood model results viewer layout. On the left-hand side of the flood model, you will find a map legend that provides a visual explanation of the symbols used in the flood model. On the top left, you will also find a home button that, when clicked, will bring you to the default extent of the map. Next to that is the base map gallery and a bookmarks tool. Within this, you will find several locations already bookmarked by the project team. Clicking on each bookmark will take you to the exact location it is referencing. For example, here's the northern bookmark and the southern bookmark. And these next two bookmarks, the Boston/Dedham and Norfolk/Wrentham subwatersheds, are saved as impact areas previously identified by the project team. To add a bookmark of a location important to you, find your specific location by zooming in and scrolling through the flood model map, or by typing in a specific location. Once you have the location, click the bookmark tool, click Add, and name your bookmark. Then click anywhere else on the screen to save. Now you can easily find your bookmarked location when using the flood model. The next button on the interactive map is the swipe feature. This feature is useful when you want to compare flood models on the map. We will give an example later in the tutorial. Next, towards your top right-hand side, you will find three widget tabs: Design Storms, Reference Layers and Critical Facilities, and a Print Map tab. The current widget tab selected is the Reference Layers and Critical Facilities widget, also labeled as Ref Layers. This widget includes all publicly accessible layers, including locations of fire stations, police stations, public water supply locations, data layers collected by the project team. These layers include the subbasins, model conduits, and 2D mesh footprints. You can read through our stormwater modeling story map linked up on the header bar here to understand each step of the modeling process and the technical terms better. You will notice that some of the layers in the widget are grayed out and are not showing on the flood model map. To view these other layers, zoom into the flood model by clicking the plus button next to the top right-hand corner of the map legend, or simply use your mouse to scroll in to zoom. As you zoom into the map, other layers on the Ref Layers widget tab will become visible, and the map legend will update to include symbols of visible layers. Additionally, some of the layers in this widget may require you to manually click just to make the layer visible. For example, to see where environmental justice block groups are in the watershed, click on the button next to the layer name for this layer to become visible on the map. This layer would be important if you are assessing who is most vulnerable in your community to climate change impacts. You can also switch off a layer to simplify your flood model. For example, if you do not want to see the watershed municipal boundaries, you can click the button next to the layer to remove it from the flood model. Next, to observe the flood model results, click on the Design Storms widget button, visualized as a storm cloud. 4 categories are in this widget: present and future storms, watershed scale solutions, priority subwatershed strategies, and historical storms. In all four of these categories, more detailed descriptions of the layers and of the storm events can be found in the CRFM glossary linked here. You can also click the gray portion of these sections to collapse and expand them. Step 3, observing and comparing flooding events. First, let's take a look at the watershed scale solutions section. This section of layers on a flood model is designed to look at solutions that could reduce flooding across the watershed. For a better understanding of the S1, T2, and T3 layers, check out the glossary I mentioned earlier. For example purposes, the S1 or Scenario 1 Watertown Rule baseline 2-year layer assumes the adoption of Scenario 1, an aggressive stormwater regulation requirement across the watershed, and shows where flooding in a present day or baseline 2-year 24-hour storm scenario will occur in the watershed. Clicking on this layer, you will see some blue pop up on the watershed. To zoom out to this layer in the entire watershed, simply click on the 3 dots next to the layer and select Zoom to. You can also select multiple storm events for your map, and they will simply overlap one another. Now let's zoom into a location to see the finer details of the Scenario 1 baseline 2-year storm. I will zoom into the northern part of the watershed in Weston. Once you zoom in, notice that your legend has been updated to include the details of other layers now visible on the map, as mentioned earlier. The legend for the flood is at the top, showing different shades of blue corresponding to different water depths, measured in feet. The lightest blue represents water depths between 0.1 to 0.5 feet. The darkest blue represents water depths above 8 feet. You can also find more detailed information for the flooded area on your map by clicking on the blue hexagonal shape that you are interested in. For example, I'm interested in what the max depth of water could flood this specific area. Once you click on the shape, a pop-up will show you the data corresponding to the shape you chose. Here you can see this part of Weston has a calculated max depth of 0.47 feet. Now let's see what the max depth is for this spot next to the one that we just looked at. This location's max depth is 2.52 feet. Remember that this is only for the Scenario 1 Watertown Rule baseline 2-year 24-hour storm event. To compare what this location will potentially experience in 2070, we can use the swipe feature. Click on the layer you would like to compare your original layer with. In this case, it's the S1 Watertown Rule 2070 2-year storm. Then click on the swipe button under your search bar. Your map will now have a swipe bar down the middle of it. On your left-hand side is the Scenario 1 2-year 24-hour storm event for present day. In your right-hand side of the swipe feature is the Watertown Rule 2-year 2070 storm event. Swiping back and forth can help you compare the two layers. Next, we're going to look at the priority subwatershed strategies section. These layers showcase how identified solutions can help reduce the impacts from flooding in the watershed. To see more detailed descriptions of these layers, again, please reference the flood model glossary. To learn more about the priority subwatershed strategies in general, see the priority site concept design story map linked here as well. Last, let's look at the historical storms and present and future storms sections. Use layers in these sections to compare historical, present, and future storms. For example, we can compare the flooding from Hurricane Ida from 2021 to a 2070 100-year 24-hour storm. Other layers include the April 2018 flood and the March 2010 calibration layer is what we use to calibrate the flood model. concludes our tutorial for using the Charles River Flood Model Results Viewer. If you have any questions about the flood model, please contact the name and email on the flood model website or go to www.crwa.org. Thanks for watching.